Have you ever built a dashboard that just felt slow? Or even worse, showed you numbers that you just couldn't trust? Well, I'm going to let you in on a little secret. 9 times out of 10, the real problem isn't your analysis, it's the data's design underneath. So today, we're going to pull back the curtain on how real databases work, because this is the foundation for every great insight.
So let's just start with the big question, right? Why does this even matter? Because whether your beautiful dashboard loads in 2 seconds or 2 minutes, and whether those numbers are spot on or just plain wrong, it all comes down to the structure of the data it's pulling from. It's kind of like the invisible architecture of a building. You don't see it, but it's what keeps the whole thing from falling apart.
All right, to make this all a bit more concrete, let's cook up a scenario. Let's pretend we're data analysts for a food delivery app. We'll call it Hungry Now. The business is buzzing with questions, and guess what? It's our job to find the answers buried in all that data.
So the folks upstairs, they want to know things like, what's our average delivery time? Where are the biggest delays happening? And hey, which drivers are our top performers? Now, here's the challenge. This information is scattered all over the place. Order details are in one system, customer addresses are in another, and driver stats are floating around somewhere else entirely. We need a way to bring it all together.
And this is where our hero comes in, a well-designed relational database. I want you to think of it like a super organized digital filing room. Instead of just a messy pile of papers on the floor, everything has its own specific drawer, which lets us find exactly what we need fast.
The basic building block of this whole system is something called a table. So for our Hungry Now app, we'd have a separate, dedicated table, a separate filing cabinet, if you will, for our customers, another one for our orders, and a third for our drivers. This separation is the very first step to keeping our data clean and manageable.
Okay, now, inside each of those filing cabinets, every single piece of paper, every record, needs its own unique identifier so nothing ever gets mixed up. That is the primary key. For our orders table, the order ID acts like a unique serial number for every single transaction. It guarantees that order number 123 is and always will be completely distinct from order 124. No duplicates, no confusion.
So if primary keys give each record its own unique identity, foreign keys are the magic threads that connect them all together across different tables. A foreign key is basically just a field in one table that points directly to a primary key in another table. And just like that, you've created a relationship. This is the secret sauce. And this little blueprint shows the whole concept in action. See that order ID? That's our primary key for this table. But here's where the magic really happens. Look at customer ID and driver ID. Those are our foreign keys. Instead of repeating a customer's full name and address with every single order, we just use their ID. It's just a simple number that links directly and efficiently to their one and only record in the customers table.
And this whole idea, this smart way of not repeating yourself, has a name. It's called normalization. The inefficient way would be to copy and paste a customer's address into every single order they make. But what happens if they move? You'd have to hunt down and update dozens, maybe hundreds of records. The efficient, normalized way? You store their address just once in the customer's table. If they move, you update it in that one spot, and poof, every past and future order automatically points to the correct new address.
Okay, so we've got the blueprint, we have our keys and our tables. So what? How does this actually help us answer those business questions from before? Well, this clean, connected structure is exactly what lets us pull on those threads and start connecting the dots for Hungry Now.
So how does an analyst actually use this thing to find answers? They use a process called a join. You'd start with the orders table to grab all the delivery times. Then you'd use that customer_ID foreign key to link or join to the customers table to find out where the delivery went. Finally, you'd use the driver ID to connect to the drivers table to see who delivered it and check their performance stats. You're literally connecting the dots between tables. And this is exactly how you'd hear a data professional talk about it. This isn't just some abstract theory. It's the practical, everyday language of analysis. By joining these tables using their shared keys, you can create one big, rich, combined data set that answers a really complex question, like what's our average delivery time, but broken down by each driver and by each restaurant location.
But look, building a great database is really only half the battle. To make sure it stays fast, reliable, and secure for everybody, it needs ongoing care and feeding. A database isn't a statue, it's a living system.
And these are the critical, behind-the-scenes jobs that keep your analysis trustworthy.
For performance, we create something called indexes. You know how a book's index lets you find a topic without reading every page? A database index does the same thing. It lets a query find a specific customer record instantly. For security, we set up role-based access. This is huge. It means an analyst can read the data to build reports, but can't accidentally change or delete it. And of course, regular backups and monitoring are the safety nets that prevent absolute disaster.
Now, of course, the real world is messy, and not all data fits into these perfectly neat tables. We have our structured data, like our orders and customers, but we're also collecting semi-structured data, like all those JSON logs coming from the driver's app, and even totally unstructured data, like the free text comments and customer reviews. A big part of the job is figuring out how to wrangle this messier data and connect it back to our clean, structured tables to get the full story.
So, if you're still not convinced this stuff matters, let me leave you with one number. This one's a biggie. A staggering 90%. That's about the percentage of slow, flaky, or just plain wrong dashboards that are really just a symptom of a poorly designed database humming away or not humming away underneath.
At the end of the day, that's what good database design is all about. Clarity. It allows the story that's already in your data to be told without friction, without errors, and without making everyone wait. So the next time you look at a dashboard or a report, take a second to think about the blueprint underneath it all and ask yourself, is it really designed to tell its story clearly?